Oh, damn. Huh. You never makes sense. You guys are very on edge. Okay. Cool. I'm just getting my color code, and I'm also grabbing some extra colors just so we can talk about what's going on. All right, so we are looking at our do now question because I want, wrong thing. There it is. We are looking at the do now question because I want us to just do some practice with this. Remember, I want to give you guys your first attempt tomorrow because I think this is actually not too bad as an internal. That also means I can give you feedback on Monday so you guys know what to then study for the rest of the week. And then we can do second attempt on Tuesday. Anyone that is aiming for top scholar of level 2 chemistry, there is some extra expectations I want you guys to do just to show that you really know your chemistry well. So that's just stuff, but I'll talk about it a bit later. Okay, first off, we're looking at aluminium, a gray shiny metal that's being burned in chloride, which is a green gas. I'll put a space there. And it reacts to form aluminium chloride, which I don't think I noted what it is, a white powder. Most things are white powders. Identify the oxidation and reduction half by their equations and combine them together for a full equation. So I'm just going to note onto this sheet that we're doing aluminium plus chloride as our two mixtures together. And we're seeing that it forms a white powder. I won't do the full justification because I think you guys can do this. It's good practice, but I'll help you guys get it started so you know what we're looking for. So may I take out the headphones, thanks? Because I'm going over the answer. Okay, so first thing is that we are dealing with aluminium and we're dealing with chloride, and we need to think about what's happening as the oxidation and reduction half. We're going to be using our resource sheet over here. So I'm stealing that because I don't know where mine is, to see where things are going. So I see that there's chlorine here, which is what I'm starting with. And the only option when I look for my chlorines is the chloride. I do have this hypochlorite ion, but that's a chloride ion, and neither of those are chlorines, so I know it's not that one. Do you see how I figure that out by process of elimination? Or do you want me to backtrack? Okay, so I'm starting with chlorine gas. So I'm looking at my resource sheet and I'm trying to find chlorine gas anywhere in these columns. I see chlorine here, and then I see it becoming chloride. So we're looking for chlorine specifically, not chloride. So that one's chloride, this one's chlorine, this one's hypochlorite ion, that one's chloride as well, and then I don't see it anywhere else. So what that tells me is I want to use this guy here. Are we okay with that? All right, I personally like to go from the equations and work my way backwards because for me, the equations really make it clear oxidation and reduction. So if I'm looking at chlorine, I would see that this guy here, I might grab another color. When I checked my sheet, it said Cl2 going to Cl minus. So one of the things we got to think about is it gaining or is it losing electrons? So we're looking at the charges of the item. So in this case, there's no charge here, and in this case, I have a negative charge. So what that tells me is that the chlorine atoms must have gained electrons. We think about Leo the lion says grr or oil rig. I like Leo for some reason. And so in order for it to become negative, we have to gain electrons because the electrons are negative. And so the gaining of electrons is reduction. So I can already identify that this reaction here is the reduction half. That's going to be the hardest part of this assessment is figuring out which guy is which. So Cl2 to Cl minus. Are we good so far? All right. So next thing I got to think about is my aluminium and where that bad boy is. So aluminium, again, look on my resource sheet. We're looking for Al, which I don't even know if I put on there because this is not a full sheet. Oh, I am sorry about that, guys. Is it on here? Okay, then I'll just tell you. Good to know. So aluminium is going to go to the aluminium ion. So Al to Al 3+. So again, looking at the charge, this has no charge. That is now positive 3. In order for it to be positive 3, it needs to lose the electrons. Losing the electrons is oxidation. So that's how I've assigned the two guys in their different spots. We good so far? All right. So something else to keep in mind when we're looking at this, I won't write this down because I figured this is a good practice problem for you guys to work through. Defining oxidation, just need the definition. So oxidation is gain of electrons. Reduction is loss of electrons. Sorry, backwards. Oxidation is loss of electrons. Reduction is gain of electrons. So you just got to write that down. It's your bulk standard definition. You're done. This is all I need for the achieved. Figuring out what's happening, giving me the definitions. That's it. So that's why I'm saying I think it'll be fine for tomorrow. Merit requirements is linking the observations to what's happening to justify how you've identified oxidation and reduction. So talking about how it started as a gray shiny metal, started as a green gas, it's formed a white powder, which is the aluminum chloride. So again, I won't write it down because I think it's good for you guys to practice. I'm just giving you the overarching beginning steps. We good? Right. Back page, for those that have the new printouts, because I did give you guys more space this time. Let's do the half reactions and then put it into a full reaction. So I like to center my arrows to make my life easier. Oxidation half we'll start with is Al to Al3+. So if I'm going from no charge to charge, this should hopefully be a reminder of ions and ion formation, I lost electrons. How many electrons did I lose? 3. So plus 3 on the product side because we're talking about it being released, given away. All right, next one is I have chloride, so chlorine going to chloride. All right, first thing I need to do is I need to balance it before I even add electrons, because you see how this is a 2 and that's a 1. The only way we can change these numbers is by adding coefficients in front, so I'm adding a 2 in front. Makes sense? All right, last thing I need to do is I need to add my electrons. So in this case, there's no charge. In this case, there is a -1 charge, but there are 2 of them. So I need 2 electrons on that side. You guys are pointing that way. I was like, this side. Because it's gaining it. It's getting added to the chlorine. Yeah? It's okay. Now, we haven't had a chance to see a more complicated balancing equation because everything I've given you, the electrons already match. In this case, the electrons do not match. That's why I gave it to you as your do now. So we need to figure out how do I get my 3 and my 2 to be the same number. We're going to think about common multiples. The common multiple is 6. So if I multiply this whole equation by 2 and this whole equation by 3, my electron numbers will match. So this whole thing gets multiplied by 2, this whole thing gets multiplied by 3, and that now prepares me to write the full equation down here. So when I go write the full equation, I have 2 times 1, so that's Al2, plus my chlorine. So I've done everything on this side. Now I'm going to this side and checking everything that's on the reactant side. I have 3 times 2. So that's 6 altogether. I don't need to write the electrons down because I will cancel them, but I will show them in case. So that's 3 times 2, that's 6, so there's 6 electrons over here. You don't need to write it down. I'm going to cancel it out. I'll show you guys why I'm doing it. All right, product side, aluminium times 2, so 2Al3+, plus the chloride, 2 times 3. Let's focus. There you go. 6. And then you'd have 3 times 2, that's another 6 electrons, and what you'll see is the electrons cancel out. That's the whole purpose of doing that exercise. And then this is your full equation. That's all it. Remember, I am not going to give you any of the complex redox equations for the assessment. Even if you are doing the extension version, I'll give you an extension question, but I won't use that as your mark. The reason why is there's nothing in the there's nothing in the clarifications that require me to do that. So why make it more complicated than I need to be? Okay? So just keep in mind for other things for your marks. Obviously, defining, which we haven't done. Observations is a merit requirement, so telling me how you know what's happening. Defining how you know things are changing with electron transfer, so this one being Like aluminium is losing 3 electrons. Each chlorine is gaining 1 electron. So remember, we're talking about it per atom. So just because that's a 2 doesn't mean you have to write 2. I'll write that down just in case. So this one is the Al atom gains, loses the electrons to form each. In this case, because we have a molecule, each that's what I mean. Only 1 atom there. This one has 2 atoms, but you need to talk about it per 1 atom. Okay? The oxidation numbers I will talk about later today. Each one, sorry, I will talk about the oxidation numbers today. I want everyone to learn that just because it's a good backup method. So if you make a mistake here, I can still use this for merit and excellence. So that's why I'm teaching that to all of you guys. Cool. Does that help with the clarifications? Yes, no, maybe. All right, it's watching our time. Cool. I will probably stop the recording and do a new one. Can I move it?
Yes.
Oh, got full equation.